ask you?
I clicked record.
Okay.
It says I'm recording.
It says, please request record permission from the meeting host.
Yeah.
Well, maybe, Steve, you can record it and share it with us.
Maybe. We'll see what happens. We'll see. The recording's starting now. Welcome, everybody, to the recording. All you missed was the slides, which are the link will be at the end. So after today, don't go to this bit.ly link at the top. That won't work, right, after today. All right. So that's it for slides until we do the wrap-up. From now on, all we're going to do is we're going to do these interactive sessions. And so we're going to start with working with geometries. So the way this works now is I want you to click on start the scenario for working with geometries. Okay. And your screen should look something like my screen. I have to go through everyone. Kat, can you go through and do it for me? It'll take me forever. There's so many people.
I can try.
Okay, try. Oh, just so everyone knows, Kat's not some random participant. She works on my team at Crunchy Data. I'm not going to call on you randomly to start recording also. Can you? Does it work, Kat? Like Jenny probably. Let's see. I can't click on the participant where?
Or host.
Participants.
Yeah, I don't think I have the permission to.
The permissions.
Yeah.
All right. So who wanted to record? Jenny. There's Jenny. More. Allow record. Who else wanted to?
Hey, Steve.
Yeah.
It looks like I've got permissions to do that. So I'll go ahead and do that.
Okay, great.
So give me a second. I'll go ahead and allow record. So Jenny, I just gave you permissions, and John, I'm allowing you. So I'll work my way through if you want to try and record. And if not, we'll just go ahead and record it offline and we'll post it something.
I'll keep recording it. Okay. So now we've started up our scenario. Thanks, Adam. Adam also works at Crunchy with me. And then the other person who works at Crunchy with me is John. So when if all of us, you might see all of us chiming in and answering questions. And John and Adam have both worked with PostGIS quite a bit as well. Kat's a bit new. So if you wanted to also say, Kat, what's the experience like? Kat is actually very close to your scenario for those people who are relatively new to it. So she can give good insight as well. And Kat wrote a bunch of the scenarios that you saw in the basics. All right, back here. So for everyone we're going to do today, there's going to be an introduction like this. The username and password for the database, which you probably won't need, is always going to be the same. It's going to be Groot is going to be the username for you Guardians of the Galaxy fans. And the password is always going to be password, the word password. I like to do that because it's bad to write your passwords down. And so this way it's easy to memorize your password with the word password. And then the database is going to I think everything in this the database is going to be called New York City, NYC. What's going to happen is you're going to click Start Scenario. After you read this, you're going to click Start Scenario. And then you're going to go through, you'll see that we're already at a P-SQL prompt. This is the command line tool for Postgres. So for those of you who are new to this, pay attention. You really got to pay attention right now for 1 second. So this is the command line tool for Postgres. So this is the command line way of interacting with the database. You'll see there's steps over here on the left side that you're going to go through and do on your own. I'll be here waiting if you have questions or anything like that. I'm going to say, hey, whenever you're done with step 1, you can either say done with 1 or put 1 in the chat so that I know when everybody's kind of caught up, and then I can go over what we're going to go through together. I'll go through the step together. Anything that's in black like this means if you click on it, it will copy and paste it over into the terminal window and then execute it. Right? Now, one thing that's going to keep biting you over and over again today is if I say, oh, go type something like the password or something into the terminal window. If you click this and it executes stuff, it's not actually changed the focus over to this window. Notice how this down here at the bottom, the NYC, the box is open, right? It's not flashing. You actually have to click on the terminal window to get the focus to change if you want to type something in, right? Well, a lot of times what will happen is the focus will be back over here after you click a black box. You think you're typing you start typing and nothing, and then you hit enter and nothing happens and you think it's broken or frozen, it's just because you haven't clicked over here into the terminal window. The other thing I think it's important for people to know, and this is especially people who are new to Postgres, is when you typing, this is a SQL prompt. So what it allows you to do multiple lines. For any of you who've used Python, this is the same thing as the Python REPL, right? Where you can do, or R, this is like the R interactive terminal as well, right? And what happens, and I see happen to a lot of people, is they'll do something, select star, like they'll put something wrong in, right? And then they'll hit enter and they'll be like, wait, why isn't it giving me an error? Or why can't I get stuff back? Notice this went from an equals arrowhead to a dash arrowhead. That means the prompt it thinks it's in the middle of a SQL statement, right? And the only way for it to know that there's an end of a SQL statement is with a semicolon. So if you see that and you keep typing stuff in and it's not responding well, a lot of times you can just keep putting in either a semicolon or maybe you didn't close your parentheses, right? There's something that you're going to need to do to finish it out and get it back to an equal arrowhead to start over. Okay? Make sense?
So use
Yeah.
the semicolon to get back to the original prompt.
Yeah, to get back, like you still may get an error statement.
Yeah.
But until you put the semicolon in, the SQL prompt is going to think that you're just adding more and more lines.
Okay.
Okay. So let's see, anything else? Oh, so because there's a lot of us also going, if you have a question, you can also ask it in the, like if you're having an error or something, you can maybe ask in the chat, because John or Adam or Kat or I can help in the chat as well. Any other questions before we get started? Okay, so your instructions are, just do step one. When you're done with, pay attention though, don't start yet, pay attention, pay attention. When you're done with step one, either verbally say done with one or put one in the chat, and then you can keep going. I hated it in school when they were go finish this page and don't go on. I was so bored just sitting there. So you can keep going if you're done with one, as long as you want. You can finish the whole exercise if you want. I won't be answering questions about later pages, except maybe in chat, but not verbally. The other thing is, this is a full interactive Postgres prompt. So I highly encourage you, if you want to play around, try something new with what you just learned, right? And play, all right? You can do whatever you want. It's not just, you can do more than just the commands you're allowed to paste in there. You have a full machine to play with for the next 2.5 hours, right? So go ahead and start with step one and let me know when you're done. Julian was like, I was tired of hearing you talking and I'm done. Thanks, Julian. Good job. Julian finished one.
Okay. Hey, Steve.
Yeah.
Maybe a suggestion. So as you're responding to some of the questions in chat, you might want to just verbally respond to them as well, since
Oh,
some
right.
people
So
may be
recording. This won't be on the
focused.
recording.
Well, and some people may be focused on the scenario and not be monitoring chat.
Yeah. I mean, I'm trying to let people stay uninterrupted while they're working, though. I find that if I talk, people stop.
Sure.
I break their flow. And I'm actually, well, once we finish step one, I'll say what I'm going to say, given how little time we have actually left.
Oh, and I saw a message in Slack that they're leaving these sessions open until 12:45 Eastern, Steve. So we do have some extra time.
Okay. I don't think I can extend the life of the machines, though. Let me just see. I set them up till 12:15, but I don't know if, let me see if I can make them last longer. I know I can add more machines. I don't think I can make them last longer, though. Let's see, edit. Oh yeah, it looks like I can. What did they said, 45?
Yeah, that's what I saw in Slack.
Okay. Oh no, environment can't be changed. I'd have to schedule a new workshop. I can still do that, but let's see where we're at. All right.
Steve, the commands in step 2 are looking for the geometries table, and that is not in this set.
It's not.
/D. No, it's in yours. It's not in mine.
Interesting. Does anybody else not have the geometry tables? So, who is speaking? Is that you, John?
Yeah, that was John from Crunchy.
That's weird. Did you see, can you go scroll back up in your window and see if everything looks good here?
Yeah, I'll go through the creates.
Okay.
Or if it looks like your screen, then it processed it and it's good to go, right?
Yes. You should have a geometries table. If you do like all the commands should be working. Or the command, if the command, I would think it would.
I can't see.
Oh wait, John, did you actually do the first step? Come back to me, John. If you don't do this first.
But I'm going back to it now.
Okay.
Oh, you did have an insert step that I missed. Yeah.
Yeah.
That makes more sense. That's on me.
Okay. Good. All right. It looks like almost everybody's done with one. Before I talk about anything else, is it a good assumption that most people here have done spatial data before in GIS? Is there anyone who hasn't done, like, what points, lines, and polygons are? Is that a good assumption?
I hope so.
That's what I'm hoping too, because this introduction is actually meant for people who don't even really know what points, lines, and polygons are. So I think what I'm going to do from here on out, because we started so late and I want to get to the good stuff, and this is mostly basic stuff. Certainly for these first couple exercises, I'm going to talk while we're going to just go through it together. Is that okay with everybody? Rather than having you read all this stuff. Is there anyone who doesn't like that idea?
No, fine to me.
Okay. And if sorry, say it again.
I think that would be better.
Okay, good. Okay, let's do that.
Agree. I think that because the SQL stuff is new and like trying to read and understand what it's actually doing in this black window is hard. If you can explain what it's doing, that would be better.
Okay, then let's do that. Okay, so everything in databases has to be in a table. I don't know if you store your data in tables. Erase that first statement I said. you store all your data in tables in databases. So the first thing we're doing in this statement here in 1 is we're creating a table called Geometries. We're giving it 2 columns. So I do like to think of tables metaphorically in my head like Excel spreadsheets. They're different, but at least that you can think of the layout being the same, right? And so we're basically making 2 columns in our table named the table is named Geometry. So like the tab in the spreadsheet is named Geometries. 1 column is named Name, and it's holding text. Varchar means hold text. Variable length. You can just call this text. In Postgres, you should actually just call this text. And then Geom, we're making another column named Geom, and it's going to hold type Geometries. Right? And for those of you who know GIS, you know that if you store something as a geometry, that means it's projected data, right? It's X and Y data. It's been turned into X and Y. So it's an actual geometry so that we can treat it with, geometric functions like X squared, the square root of A squared plus B squared. I don't know. I can't even remember because I'm on the spot trying to remember middle school geometry. But you can use normal geometries on the geometries. Does everybody understand that we made a table here, like a tab in a spreadsheet? We're all good?
Yeah.
Okay. This next statement is we're saying we're going to put data into those geometries. So we're going to insert a point. We're going to give it the name point. And then this is how you make a geometry. You say it's of type point, and the coordinates for that point are 0, 0. So if we were on a piece of graph paper, this is at the origin, right? We're making a point. You want to make a line, we're going to call it a line string, and then the line string starts with line string, and then it's a set of points. So the first point is 0, 0, the next point is 1, 1, the next point is 2, 1, and the next point is 2, 2. Make sense? Okay. Then we're going to make a polygon. So a polygon is a collection of points, collections of lines, actually, right? So that's why we have the double brackets. So there's the outer bracket for what might be a collection of lines. What makes it a polygon is that the line begins and ends at the same point, right? So it's closed. Otherwise, it'd just be a line, right? And then that collection of lines you see happens for a polygon with a hole. So this one, the outer one, this is the outer line. It goes 0, 0, 10, 0, 10, 10, 0, 10, 0, 0. That, for those of you who worked with geometries a lot, that's a box, right? So we make a box, and then inside that box, we're making another polygon, which is 1, 1, 1, 2, 2, 2, 2, 1, 1, 1. So that's why you need a collection, because you can have holes inside of polygons, right? And then a collection can be a collection of geometries. So I've never seen people really use geometry collections that much. So what we're saying here is this geometry column is a collection of different types of geometries, right? So you might use that. The example I could think of is something like in oil and gas industry, where you might have, where you call a site might have the actual drill hole, but then also a polygon for the pad, right? But most people I know don't use a geometry collection. They actually break that apart. So, and then what we do at the end here, select is the way you query back your database. So we're saying select the name, and then we're doing a function on the geometry column, and the function is called st_as_text. So for every row, give us the name, and for the geometry column, run this function st_as_text, which you'll see turns it back into what we put in, right? So if I do, let's do this let me copy and, actually I'll click here, and now I've inserted 15 rows into my table. But you'll see it gives back this st_as_text, right? And it looks exactly like we did. If you didn't do that, right? If we did just select, see, it just bit me there. I didn't click on the terminal window. Select star from geometries. You'll be like, wait, what happened? What is this thing here? This is, PostGIS actually stores the geometries as binary, in binary format. So this is actually the binary representation of that point. This is the binary representation of that line. This is the binary representation of that polygon. This is the binary representation of that polygon with a hole. All right, so you use STS text to get it into human readable format. We good? Everybody says, yes, that's awesome, Steve, thanks. So there are metadata tables in PostGIS that store information about your geometry columns. So the first tables that we talk about is Spatial Reference System. So for those of you, you guys should know about projections. This is where you store all your projection information. Right? This is that lookup table of, here, let me pull one. Oh, if you ever see this where it says more and we're in the terminal, you press Q to get out of it. Okay. And if you want to bring the window all the way back up to if you want to bring the command prompt to the top, you just do Control L, and that clears the window and brings it up to the top. So the Control key and the L key. So if I do select star from Spatial Reference System, limit 1, I only want one of them. This is EPSG 3819, right? And then there's all that normal projection information you see. So in a shapefile, if you open the .prj, you'll see something very similar to this, right? So this is just defining the projections. The second table is a view. It's the geometry columns. And so if we do select star from geometry columns, you'll see which table has geometry columns in it and what's the name of the geometry column. So this is the table we made, right? It's in the schema named Groot. The table name is Geometries, and the geometry column is Geom. And what's the projection of it? And is it 2D or 3D? And what's the type? Okay. I almost never use that, but some people might find that helpful. If you go into a new database and you want to know, where's all the spatial tables? You can do this, select star from geometry columns. Okay?
Steve, a question came in through chat again about asking what the numbers refer to. I just want to point out that the numbers in PostGIS aren't specifically latitude and longitude.
Right.
PostGIS can hold any reference system you want. So in the example where we're setting them up, the 00, 10, 11, it's more like drawing points on a piece of grid paper. Since you don't have a reference system, you don't actually have anything that it's projected to or doing anything against.
Exactly.
So
you'll see
it comes up later.
Yeah, we'll definitely bring that up later. So it's the same thing as you've probably done this before, like when you open up a projected file, right? In the graphics person, right? Melinda, you probably don't have much. Yes, Melinda, this is actually much more like in, I'm assuming Melinda, right? Melinda, are you the graphics person or is that Melissa? No, you're the project manager. Is that right, Melinda? Yes, Melinda.
Michelle.
Yeah, there's too many M names. There's like 3 M names in there. It's hard for me. So Melinda, this is very much, we'll get to what this is. This is just arbitrary coordinates right now, like on a piece of graph paper. Just 0, 0, 0, 1, yeah. Anything else? I think we're good. Let's go on to the next exercise. So now we're going to do real world objects here, right? So this talks a lot about the simple feature spec for SQL. The reason why you would care about this is the OGC has come up with a specification for what database, to be a spatial database, what you have to be able to do. And that's what we're trying to observe here, right? And we have a lot of the functions as well too, right? So the next question we're going to do is we're going to say this question has a bunch of the normal functions in it. So what we do here, right, is we're saying, hey, give me the name. What's the geometry type? How many dimensions does it have? And what's the projection from our geometries table? So since I did that first command 3 times, I've got 15 points. You should only see this repeated once. And so you can see, oh, it's a point, it's 2-dimensional, and we don't have any projection information for it. It's 0. Okay. Melinda, projections, we'll get to projections. Just let that term wash over for you for now. You'll see what projections means in a bit. Okay, so
So Steve, just
yes.
reference. So prior, when you read the exercise from the beginning, the table and everything was preset. So perhaps people who haven't done it before might not know what was done to begin with in order for you to do these queries and select and draw from that database.
Well, we actually did. The only thing that we did here that we didn't, that you would normally wouldn't have done, this statement here on 1, we actually created the table and put the data in. The only thing I didn't do here, which you would need to learn to do, is in this database, we said create, as a super user, we said create extension PostGIS, right? But here it already exists. We did that because of how we spin this up. PostGIS is already installed.
Okay.
On a normal PostgreSQL database, you would have to say create extension PostGIS, and that installs PostGIS into the database for you. And then you can just use it. Okay. All right. So the thing that's, what we're going to do here is now go through a couple different ways of getting stuff back about your the geometry column, right? So we already did this one, right? But you can actually, if you want to, get just the X and the Y's, right? So this is another one of those simple, what do they call it? What's their SFSQL, right? The simple feature spec. One of the functions is STX, STY. So if I do this one, right, it gives back the X and the Y where the name equals point. I put it in 3 times, so we get 3 of them, right? If you do it, you should just get 1, 0, 0. But it gives, you can get back the X and the Y separately, right? And then here's a real one. We actually preloaded already the New York City subway stations. And if we pull this back and we pull back just 1, you can see the Cortlandt Street subway station has these coordinates. And these coordinates for this point are actually in a projection. So if you remember, if we go back up to this statement, the subway stations, it's in projection 26918, which is probably New York State plane, would be my guess. We can actually look it up, right? Where was that query I did? So we can say where SRID equals, what was the number again? Does anybody remember off the top of their head? 26918. 26918. Oh, I forgot to get rid of the limit statement. The actual limit word. I got rid of the 1 there. So that's the projection. It doesn't have any name information with it. I think it's probably a New York, probably some sort of New York State plane. But that's what those coordinates are in. Right. So we already did this one, right? The geometries for the line string. But the other fun stuff you can do on a line is you can ask for things like length, what's the start point, what's the end point, how many points are in it, right? So if that line that we made before, we can say things like, tell me what's length. And its length is 3.4144, blah, 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 right? That's the length of that line, adding up all the individual segments between the points. And then the polygons, we already did this before, right? Where we said, show me anything that's like polygons. There's a whole bunch of really interesting functions we can do there. You can ask for like the area, how many rings does it have? Give me the exterior ring, give me the interior ring. So like the one with the holes, you can do, right? You can ask for the interior ring. You can ask for the perimeter, perimeter is the length of all rings. So in this one, we're gonna do the area for anything that has the name polygons. So there we go, right? Polygon with hole and polygon. The area is 1, the area is 99. Because we made a box that was 10 by 10, and then that box in the middle was 1 by 1. So we subtracted 1 arbitrary unit from it, so we get 99. Make sense? So for those of you who are GIS analysts, you can already see that if your data is projected and someone comes to you and says, give me, hey, what's the area of these polygons in this data set? It's very easy to get the answer here. And if you're working on a project where the areas are constantly being updated and you just want to spit out a report that says, what are the new areas? it's very easy to write a function that can actually just every night run and spit out the areas for all the polygons with their names, right? And so people can see, or you can actually even do things like, you know, divide it by something or multiply it by something once you learn how to do SQL, without having to open up a GIS desktop and open up the tables and look in the tables and sort by area. Or you can do a very simple question. You saw me do the where query, right? So I could also take the same query for you working at home, like for doing something automated. You could say where name like Polygon. So you say, oh, this one, and you can say and st underscore area of geom greater than 1. And now all we get is the polygons with holes, right? So you could say, you know what, whenever any of these, like let's say you were doing fire management, whenever any of these fire polygons get bigger than X, like, you know, bigger than 100 acres, kick off the next level of stuff, or send a report out or send an email, you can start writing queries like that, where you can say where type equals fire and area is bigger than 100. If your unit is in acres, you're probably going to store it in feet, and then you'd have to do the conversion in the query, but you get what I mean. Does that make sense?
Mm-hmm.
Okay. So collections, I'm just going to skip collections because you can use them. I guess multi-polygons is the biggest collection you'll probably ever use, or multi-line strings sometimes, or multi-points. Sometimes like a drill site can be multiple drill holes. That's what I've never really seen people use geometry collections. Have it, John or anybody else here seen people use geometry collections?
A lot of times it's used internally as a transform within the data, so it's a more advanced topic at that point.
Yeah, you'll be very, very deep in before you get to geometry collections. I do see people though using sometimes like multi-polygons, especially when coming from shapefiles, because sometimes shapefiles and other data coming in sometimes has multi-polygons as its type, and when you import it, it comes in as multi-polygon, but usually it's just a single polygon in there anyway. Okay, so I'm just going to skip that.
So Steve, is a multi-point something like a stacked point?
It could be a stack point, or it could be like what I talked about before. Like here, for the row, the name is drill site 1, but drill site 1 actually has 3 different boreholes.
Oh, okay.
Does that make sense? Like there's
Yeah,
3 different holes, and each of them are different in space, but that's a multi-point. So that row is made up of multiple points. Does that make sense?
Yeah, yeah.
Okay. I mean, sometimes you see multi-polygons. Actually, so a multi-polygon, this would be a good use case would be where Adam lives. Adam lives in Wisconsin. And so if you did the state of Wisconsin, there are a lot of islands which make up the state of Wisconsin. And so you would say Wisconsin is a multi-polygon because it's the big peninsula, but it's also includes all the little islands. So there'd be multiple polygons that make up the state of Wisconsin. Does that make sense?
Yeah, I think in ARC, we just refer to them as like multi-part polygons, but
Exactly.
It's still a polygon feature class. It's not a special type of feature
Yeah.
class, whereas points are either a point or a multi-point. Like you
Yeah.
can't do a multi-point in a point feature class. You have to use the multi-point.
Multi-point. Yeah. So here we have I think it's considered a multi-polygon. Wisconsin would be a multi-polygon because it's multiple polygons. The island is that. It's not like the whole is different, right? It's not a whole. They're separate polygons that make up this entity called Wisconsin. Even California, most states have multi-polygons, right? Even if you had like an island in the middle or something. No, I don't think an island in a lake would be. But California, most coastal, or anyway, never mind. Moving on. So, step 3, this is geometry input and output, right? We have a whole section on this later, but what we're going to do here is we're going to, if you wanted to insert, like remember our insert statements before, way back up here, were just line string with nothing else in them. Here, you can actually say stgeom from text. So I want to make a geometry from text. It's a point, so you put that part in quotes because that's a string that's a point, right? And then you give the SRID. And so if I do this, and I go down here, that's actually the binary representation of that point in projection 26918. Brett, since you actually went to the site, what is, if you have a microphone, what is 26918? Is it New York State Plain?
It's NAT 83, 18 North.
Oh, so it's UTM.
Yeah, it's an older one.
Okay.
Yeah, I don't know if anyone wants to check that site out. If you're ever looking for projections that might be appropriate for a certain area, or if you need to have it, the projection.
There it is. There's this one. Yeah, so MapTiler has one, and then the other one I know of is I think it's Spatial Reference .org. So this is another one, right? So we could put in, the nice part about, it's probably the same as MapTiler, but what was there? 26918. Right, you search that, and it says here it is NAD 83 UTM North, and then you can go here, and then it gives you all the different formats you need for it, if you need it. So, all right. Thanks. So it's UTM 18 North. All right. So the other thing is, if you can also say ST binary, you can say ST as binary right here and give it in hex format. You can do it, but I almost never do anything like that. Usually what I'm doing is I'm putting points in like this, right? If I write my own insert statements, like I'm writing a Python script or something, or someone gave me a CSV file and I open it in Excel, and then I do a little concatenation and I make point look like that, or polygons, or what points actually usually, right? And then I just make a bunch of insert statements and they all look like that, and I put the projection information if they gave me projection information, right? So let's see, what else do we want to cover here? So the text representation can change. Why did this one change? Because here we're changing the text representation here. It can consume all sorts of different things, right? But because these points actually are three-dimensional, do you see that? 0, 0, 0, 1, 0, 0, 1, 1, 2. It's saying, oh, this is a three-dimensional point, right? It understood that geometry text means it's just a three-dimensional point. And so now it comes back as a line string with Z meaning the third dimension. All right. And then there are many other ways to create geometries. I'm going to skip most of them for today because you can come back to this exercise another time if you really need it. The reason I'm saying skipping is because I want us to try to get to the really good stuff, which is the queries and stuff that come later. You can also import GeoJSON, right? So you can do GeoJSON, or you can return GeoJSON, sorry. For those of you, this is actually giving us back GeoJSON, but you can also do it from GeoJSON. For those of you who don't know, GeoJSON is a JSON, JavaScript object notation format that's specifically a standard for dealing with geometric data. According to, if you're strict about the GeoJSON standard, your data has to be in EPSG 4326, but people use it for all sorts of other stuff. So, okay. You can also, so casting from text. What that means is, see these double colons? What that means is I'm saying select point 0, 0, even though this is a string, cast this, or cast means like treat this like a geometry type. Okay? So make this into a geometry. So take this point and make it into a geometry, right? So we get the binary. And so here, I'm going to make it into a binary with a projection information. Right? So double colons means cast or convert this thing before the double colons into this thing after the double colons. Make it into this type. It's a data type. Does that make sense? I'm assuming that yes, that means yes.
I would assume that I'm asking why.
Because sometimes you're inputting something that's just a string, and you want the database to treat it as, take that string. The string is a valid representation of a geometry, so treat it like a geometry.
It's also a deeper coding problem, because if you have a function that only takes in characters and you provided it in an integer, it's going to break. So if you have a character that you know is numbers and you cast it to an integer, that function will then work on that integer set. It's a functionality of Postgres in general that the cast just goes across everything.
Right. It's a general database thing. So here's something else I should explain. I'm used to people who are using databases. See how this select SRID, everything before the double colons is in a single quote? That means that's a string, right? And so if you had a function that took in a geometry, like John was saying, if you just passed in the string without the double colons, it would say, I don't know what to do with a string. My function says I take geometries. So you'd have to cast it to a geometry, right? Or if you didn't do, so if I tried to do something, remember there was the, this is a point. What was one of the functions we could call on a point? Where was it here?
STX?
Yeah, STX. So if I try to do, if I don't cast this to a geometry, if I just do a string like this, and then I do st underscore x, capitalization does not matter for function names, by the way. If I just do this, oh, it works. I don't know. It shouldn't have worked. It's smart enough, I guess, to know. What's that?
Yeah, it's implied with something.
With something. Somehow PostGIS is smart enough. Paul Ramsey probably decided people aren't going to always. It shouldn't have worked, because if I put in this, like STX, and I put Steven, it says that's not a really geometry. So STX is smart enough to know to go in and say, hey, first check to see if this thing looks like a geometry, and if it is, treat it like a geometry. But in general, even though this is not a geometry, you would, if people aren't coding as defensively as they had, you would have to say something like that. It's still it's not a geometry, right? But you would have to cast it. That's what casting is about. Does that make sense? That sounded like Melinda. Was that Melinda?
Michelle.
That was Michelle.
Michelle number 1.
Michelle number 1. Oh, not graphics, Michelle.
Project manager.
Wait, I thought Melinda was the project manager.
It doesn't matter.
Wait, Melinda, are you also a project manager?
I don't think we have a Melinda.
I thought, yeah, we have Melinda Meek.
Yeah, she just said yes in chat.
Yeah.
Two
Okay.
Michelles as well. That's the confusion.
That is not fair. That is totally not fair to have 2 M names both being PMs. All right, fine.
Melinda Meek, though.
I know, but it's still, I'm not going to get it. Anyway, so what were we on for? Okay. So like, for example, what we're doing here is we've got a bunch of different, this is to have you work through some exercises. Do you guys want to do these on your own? Or did I just do them? Can I just do them?
Yeah, go ahead.
Okay, because I want to get to some of the more exciting stuff, the more GIS-y stuff. But I showed you this before, right? So this is the New York City neighborhoods, and here's the West Village. UTM gives its answers in meters. It's projected. So for the 2 PMMs, right? I'm going to call you guys PMMs, even though that has a very specific meaning. The PM, Melinda and Melissa, who may not know as much GIS stuff, these UTM gives its units back in meters by default. And so what the note is saying is this is square meters. If we want to get this into hectares, we have to divide by 1,000, right? So if we wanted to make this into hectares, or to get it into acres, since this is America, we speak American here. Let's make it into acres, right? What we would do here is we would say divide by 4707. And then if we wanted the column name, rather than to be ST area, which is not very helpful, we could say as acres. So return the name, give me back this thing and call it acres, right? And now you'll see it says acres. So the West Village is 221 acres. It's not that big. I thought the
But
West
you
Village
have to write that all the time unless you change the main database name, right?
Oh, you mean I have to say as?
Yeah.
Yes. Well, and even if I change the main database name, I would still have to write it, because if you notice, what it's actually calling the column is the function name.
Okay.
Right? It's very, very common in SQL to use the as statement, because usually you'll have functions, or the database name might be something like geom underscore or first underscore name and last underscore name, and you're going to want to give a more user-friendly response if the report's to be just consumed by someone directly, right? Okay, what is the area of Manhattan acres? So the hint is New York census blocks and New York City names have a borough name in them. So we can say where borough name equals Manhattan. So that's the total acreage of Manhattan. Okay. Oh, but it's a different answer depending on whether you go on census blocks or borough name, right? Or between, wait, what is it? From New York City? Oh, census, the neighborhood file versus the census file have different size differences. I wonder what that is. I wonder if that's like not Ellis Island. What's that island off Manhattan in the Spider-Man movies where the tram goes back and forth from? I don't know. Do you know what I'm talking about? Does anybody know what I'm talking about?
Ellis Island, Staten Island? You mean this?
No. Those are both not part of Manhattan. There's that Governor's Island. Is it Governor's Island? Ellis Island, Statue of Liberty. Is it Governor's Island? I think it's Governor's Island. Anyway, I guess I'm talking to DC people.
Roosevelt
Island. Thank you.
There's also a small portion of Manhattan that's on the Bronx Peninsula.
Really? I did not know that.
So
okay.
Depending on what it's talking about land-wise.
Yeah, exactly. Cool. All right. How many census blocks in New York City have a hole in them? So this is another type of SQL that we can do. This is another good SQL introduction. Let me do this, Control L. So this one, 43. So we're doing select count star. So what we're doing is saying, if I get rid of the count star, let me show you what comes back. All right. So oops. No. Okay. What you'll get here is we're going to get one of these columns is very large. It's probably the geometry column, actually. So let me just get, give me a second. What were the column names? Let me get the block ID. Let me just get that, let me just get the block ID or the GID rather than select star. Select star, sorry, you probably don't even know if you don't know SQL. Select star means give me back all the columns. Okay? And so what I'm going to say here instead is select GID, right? And what we're going to get is 48 rows if I go all the way to the bottom, or 43 rows. So if you say select count, when we did this, count star, it's basically just saying, give me back the count number of rows where from this table where we meet this this condition. And so what we did here is st geometry n. So where the geometry is 1, right? And then we say number of interior rings is greater than 0. So if where there's actually an interior ring. And so that's what gets us 43. So with interior rings, it's basically saying where there are interior rings greater than 0. Give me how many rows come back, and we get 43. Right? And so that's another, again, you have these nice functions like count. Just give me the number of rows, right? Rather than having to go through the Excel spreadsheet and like, okay, look at the number on the left side. It's 43. There's 43 rows, right? You can actually script it. Okay. Here's another, right? There's another function that you can do in SQL. Sum, right? So here we're getting the New York City streets. We're dividing by 1,000. So this is kilometers, because remember it's all in meters. And the function that we're doing is we're saying get the length of the geometry, get the length of the line, and sum them all up. So sum up all the rows together. So there's 10,000 kilometers of streets on the island in New York City. Does that make sense, that SQL query? Right? And again, this is really nice because all we wanted was one number. Like let's just say somebody says, how many how many kilometers of roads are there in this county, anywhere in the United States, you don't actually have to load all the roads into your GIS and then run the sum function over in the GIS. You can run one SQL query, get one number back, and you have the number right there, right? Rather than running some sort of geometry function. How long is Columbus Circle? So this is, let's see how big that is. Meters, it's 308 meters. That's the length. What is the JSON representation? So if you ever work with a web developer and they want, hey, give me the JSON for the West Village. You can say, okay, here, there's the JSON. And then they can use that in something like any of those web mapping programs, like OpenLayers or Leaflet or any of those other things, and they can use that to actually draw that on top of a web map. Here's the number of geometries. So there's another function called number of geometries, right? You can say, give me the number of geometries in the West Village. And there's only one that has West Village. So this one is actually what we're doing here. Now we're doing a group by query. So, God, there's a lot of SQL, you guys. You guys must feel overwhelmed already. Do you feel overwhelmed with all the SQL I'm showing you? I don't think you should try to totally understand the SQL that I'm showing you. Just know that this is available, right? And that you're going to need, this is powerful. I can learn this and do it later. So what we're doing with this query here is we're selecting the type of road, because we're going to get these all from the streets, right? So the type of street. I want you to sum the length as length. And then I want you to group, but I want you to sum not all, which is what we did before. That's just the total length of all the streets in New York City. What I want to do is I want you to break it out by type. And then I want you to order the results by the length descending, right? So greatest first, and then least at the bottom. And so what we see when we get this is there's a type, the type of streets is, there's residential, there's motorway, and this is the sum of the lengths of those different types, right? So like steps, there's 282 meters of steps in the New York City database. Right? Does that query make sense or not make sense? I hope you don't have, wait, it was Michelle, I think, that asked last time. I hope, PMM, Michelle, that the why is clear in this one.
Yes, thank you.
Sure. I'm just playing. If you can see my face, which you should see that I'm smiling when I do this. I like to joke around a lot. Hold on one second. The sun is now finally risen over the mountains, and I am blinded. Okay. All right. So I think that does it for geometries. Yeah, there's a whole bunch of functions. There's tons of functions. We can't do them all today. If you want to read the docs. Okay. Let's go on to the next one, working with geographic data. Do you want me to keep doing this format? Do we want to take a break for a minute? We've been going for almost 2 hours. Well, we haven't really. We've been going for an hour and a half. How about we take I've got 10:55 here. Is that what everybody else has?
Yeah.
All right. How about we take a 5-minute and come back at 11?
Sounds
and
good.
Okay.
Okay.
We'll work with geographic data. And I'll do the same thing. I'm just going to go through it. Is that okay?
Fine.
Yep.
That's good.
Okay. All right.
Can we ask questions during the break, or do you need to?
You
actually
certainly
leave?
can. I do not need a bio break right now. So
Okay.
let's ask questions.
So, like backing up, like a lot of steps.
Yes.
How do you even get started? Like, what do you open to start with PostGIS?
So
Loading data can be pretty difficult.
it depends on, well, it doesn't have to be though.
It doesn't have to be.
So are you asking about loading data, or are you even just saying, how do I even get started with, like, someone told me they installed Postgres for me and I need to know, how do I even get started that way? How far back are we
So
going?
you answered part of the question. It's an installable thing.
Yes.
Like it's not just a web thing.
No.
Okay.
I mean, it's a web thing. I think it was, you're Michelle, is this Michelle from the PMM, Michelle?
Yeah.
Okay, I can't see the cameras, sorry. Cardo, it is a web thing for you, right? Because you just load up Cardo. if you wanted to put it on your machine, right? There's PostgreSQL on a machine. There's PostgreSQL.org and there's downloads. And so you would install it, like they have a Mac OS, they have a Windows installer. You would install it locally on your machine if you wanted to use it locally on your machine. Or there's plenty of, like, if you know about Docker, there's plenty of Docker containers. We have where you actually, you don't know it, but there's a Docker container running under the hoods running Postgres today and what we're doing. Then, after you do that, you would go, if you wanted to learn more, actually, if you go into PostgreSQL for application developers and you go into basics, there is a class on how to run it in containers. So do you have Docker on your machine, Michelle?
No, I don't
Okay.
know what that is.
Okay, then don't worry about it. You would just install the binary. I don't want to get you into containers. Then you would probably want to start using introduction to using the command line, just to get you started. But the other thing, right, so this just teaches you how to use the command line that we're using today. Does that make sense?
Yep.
Okay. The other thing, though, is do you have QGIS on your desktop?
Yeah.
So let me fire up QGIS. We're not going to cover this today, but I wonder if they're covering it in the QGIS class.
While he's doing that as well, Michelle, to your earlier questions about debugging performance issues, there's a lot of ways to go over that. If you want to send me an email separately, I can talk to you a little bit about that. My email is john.porvaznik, Porvaznik, @crunchydata.com. And knowing that this is being recorded and now everyone has that email, I will also put it in chat here. And I can try to give just some high-level thoughts about some of the performance issues with PostGIS.
Yeah.
I do that with a lot of clients.
Yeah. And part of that depends on how much, the ability for you to tune that or not tune that or be aware of that or not be aware of that. I don't know enough about the Carto. If, there's an AMA for Paul Ramsey this afternoon.
That was the other suggestion. If you stick around for the second part of it, I'm sure Paul will have some of those suggestions.
Paul worked at Carto for
the way polygons are stored versus the way the index uses them.
Paul will know all. That's a great question for Paul. In the Ask Me Anything for Paul. How do I diagnose performance issues in Carto? It's a good one. PostGIS performance issues in Carto. So the other thing I was going to say is in QGIS, there's a database option. And you can say DB manager. And I think, let me see if I have my containers running. Come on, PowerShell. Come back to me. What's going on here, PowerShell? Oh, okay. Docker. Yes. I'm running DDApp. DDApp does not. Okay, hold on. Docker stop DDApp. Docker start contrapest. Okay, so in QGIS, you can, where is it? You can, we're having a database manager. DB manager, is it not coming up? All right, doesn't matter. We can do it here. So we can do PostGIS, we can say new connection, and so you have your PostGIS running on your local machine. I can say contra, right? This is any name I want to give it. The service doesn't have a service. The host is localhost. The database is, I think it's contra pest _ trial, right? Basic authentication. The username on this one, I think, is, I don't remember what it is. I think it's dev user, and the password is password. Let's see, test connection. Connection was successful. So I say okay, right? And then that shows up in here, and I open Contra. And the name was dev user. Password was password. Right? And so there's trap data, right? And so I can open that and there's the data, right? So this is all reading out of PostGIS. If I had a shapefile loaded here, I can then say, I forget exactly where again, because I haven't done it in a while, but you can just say import the data. And you can import it from the shapefile through QGIS into your PostGIS database. And it'll retain whatever shape information, whatever projection information the shapefile has. So for desktop users, I think that's the easiest tool, is to use QGIS. There are other utilities like shape to PGSQL, but that's all command line stuff, and it's not nearly as easy. Does that help?
Yeah, that's cool. Thanks.
Sure. I mean, yeah, we should actually at some point, another good workshop, once we have enough people using PostGIS and QGIS, another good workshop would be PostGIS for QGIS users, where we show how to like do the imports, right? Because you can actually do things on your layers here, where I think, let's see, no, it's not there. There's a way to make a new layer where you actually put the SQL query in the layer, right? So you can do all this. You can also do all the SQL processing on the server, and then just get the results and display them in QGIS. Right-click the layer, and it should be there. Where do you see it? Export layer. Oh, or maybe I double-click the layer. No. Oh, you mean the layer down below? Sorry. Duh. Right. You can just say update SQL layer. Right. No, that's not what it is. Sorry. Where's the layer properties? There. So if I bring this over here, I think there's somewhere in here, right? Help me out here, Brett.
Oh, man,
Field name. Here's all the field names, relations. Oh, no, it's here. It's here. It's here. It's here. Where is it? Help me.
I'm used to it with the SQLite layers where you can just take a virtual layer out of it.
Where's there somewhere in here that like source? Oh no, source. Is it source? No, filter. Yeah, query builder. So I could say trap name equals. No, I want treatment zone sample. Anticoagulant trap where treatment zone equals anticoagulant, and you say okay and apply. You say okay, and you'll see now that those are the ones that meet that criteria. So in that same SQL query that we did before, where was that? Properties, right? Where'd it go? Did I click? Yeah. In that, so here in the query builder, I could have actually written, there was nothing fun to say with points, sorry. But you could do things here like, if this was a line, you could say where length is greater than whatever, and it would only return the lines that were that way. Or you could do your whole clip operation here if you wanted to inside of this, right? And the result, the coming outcome layer is only the result of the clip operation. Does that make sense? So
one of the nice things, I'm going to jump on Steve here too, is since he's using QGIS to do this, is the fact that all of this is hooking into the same Postgres and PostGIS background. That's one of the nice functionalities of it, is that your access method can change, but it's the same data for anyone or any analyst, so they can all use the same analyst tool. ArcGIS, QGIS, one of the crunchy tools, open layers, leaflet, etc.
Right.
It's all back in the same data.
Exactly, and that's what I was talking about with it's all one coherent data source, right? So your web app developer can be hitting this exact same database with just read permissions, let's say, and they're displaying this data. You as the GIS analyst who has write permissions, you come in with a different account that has write permissions, you can update the data through QGIS, and that change will be live in the web page right away, right? It's not like, oh, well, I'm working on this shapefile. Here's the shapefile, import it into this thing that, you know, spit it out to GeoJSON and update the web layer with this new GeoJSON. It's all live immediately, right?
And where does that live? Is that in the Postgres SQL database that we're making the changes? And that's where I'm a little confused.
Yeah, so you can think of PostGIS, you could think of, I mean, in a very, very broad way of thinking of it, you could think of your Postgres database that's running as a collections of shapefiles inside of this application. So Postgres sits there serving up data for you. It's a database, right? It's not a single file. It's a database, and it serves up lots of files. And you can connect to Postgres. Here we connected with QGIS, but you can also connect with Python code or Java code or whatever code or JavaScript code. And that's what your web developer would connect to the exact same database running on that machine using code to make the web map. So there's this, if you can think of it, there's a server running on some machine that you're connecting to as the database analyst using QGIS, and every other user is connecting to it using whatever method they want, like the web developer might be connected with Python to do a GeoDjango app or something like that. Does that help clarify where it is?
Yeah, and then we use PostGIS we could alternately use PostGIS to do some of the same thing that you're doing in QGIS, is what you're
Exactly, and you'll see that
Okay.
later. You'll see that later. The one thing that is hard, though, right? For a lot of us as desktop who started as desktop people, you're like, well, most of my things are graphical, right? You can't get the graphics out in PostGIS. I mean, you could through a bunch of extensions, and if you wanted to write a bunch of functions, you could probably very awkwardly make it render a image somewhere on disk somewhere, but that would be way more pain than it's worth, right? So the way you think of it is what you're doing is you're using PostGIS to do all the operations and then QGIS to do all the graphical display of your operations. Does that make sense?
Got it, yeah.
Okay. I'll leave QGIS up. Oh, except I don't have this database. Maybe in the next break, I'll bring up this database as well. So for people who want to stay in the next break, I'll spin up a container, load up some data, and then we can play with it a little bit in the workshop.
Just if I can interrupt just a quick second. Sure. I was watching the pull request on QGIS GitHub, and there's been a number of fixes that were put into the database driver for the PostGRE SQL to improve performance, because I guess the way QGIS was querying the database, it was always casting the indexes as text, and it was making the queries take like inordinately long. Okay. So people were having on the QGIS end like tons of trouble with why is connecting to this database so slow, and those polls should be coming through for 3.14, I think. So if you've had customers with those issues, hopefully, fingers crossed, that's not a thing anymore.
Okay, so cool. So the long and the short is I'm on 3.12, right? And so the long and the short is as soon as 3.14 comes out, if you're going to be using PostGIS, update. Is that right, Brett? Is that the long and the short? I think that was what Brett was saying. Okay. All right. Back to our exercises. And I don't know. So you might be able to do this with PostGIS and ArcGIS Desktop. It's been a very long time since I've worked at Esri. I worked at Esri for about 1.5 years back in the early 2000s, and I haven't really used their desktop software since. I've just been using QGIS since then. So I don't know, or I haven't been using ArcGIS to connect to a PostGIS database. So I don't know if you can. If someone has done it, that would be awesome to hear. I don't know if they're nice and support it directly.
They're supported, but if you're in an enterprise or like multi-user, you can't share the database connection in your project file. So if you're sharing like an MXD, you have to have Arc server to share that connection across the whole organization. Or everybody has to manually connect from their machine to the database. So that's just like really frustrating, as opposed to like with Q, if you have the connection in the project file, as long as everyone's on the network, they can all connect.
Okay.
It's a mess, but you know.
I mean, I'm gonna bite my tongue, especially since we're being recorded. Okay, so let's go back to our exercises. So the next part we're gonna talk about, and I'm gonna go through this one, I think relatively quickly, although it might be interesting to people here as well, is the geography data type. So the type we dealt with before was geometries, and geometries is what it means, is a geometry. The geography is the type that is specifically the X and the Y are longitude and latitude, right? This is specifically for dealing with points or features on a globe, right? So there is no projection. I mean, there's projections due to the datums, but there's no projections to a 2D coordinate system. if that makes sense. So this does, when you calculate length, like, so if you're dealing with large areas, so for those of you maybe in the military or in a national government agency or some large corporation, and you're trying to figure out distances between New York and Los Angeles, or between the United States and Berlin, DC and Berlin, you're going to want to work, and you want to calculate distances, you're going to want to work in geography data types, right? Because those will actually calculate great sphere distances. We'll talk about projections quickly in a little bit, but this is actually for things that are spherical. Not all the functions in PostGIS, like all the calculation functions, are supported in geometry types, geography types, sorry. But it's much more accurate for points on the globe. So this is longitude and latitude for Los Angeles and Paris, right? And so you can say geometry from text. So the type is actually called a geometry type. Right, so let's go ahead and do this. Right, there's our geometry from text. We're actually calculating the distance between Los Angeles and Paris in this function, right? The problem is, oh, actually, sorry, in this one, we're using geometry. Let me back up a sentence. This is using the geometry types in this one, right? So you're saying, oh, I don't need geography types. Let's just use the geometries. We'll put in the lat longs. We'll use 4326, which is unprojected, and go ahead and calculate distances. The distance it gives back is 121. What do you think those distances are? Don't read. What does 121 mean in this case? Somebody take a guess at what 121 stands for. If you think about what geometry does, right? What are the units in geometry? That's a hint. Come on, be brave. I'll be nice to you, I promise.
I think you're getting some responses in chat, Steve.
So it's decimal degrees. Yeah, people are putting it in chat. Yes. That answer is what? Yeah, the distance between Los Angeles and Paris is 121 degrees, right? And the problem is, as we as geographers know, degrees are not constant on the globe, right? So you can't even do some straight conversion. There's a Haversine formula to actually convert that into like an actual distance of the globe, because degrees change depending on where you are on the globe. 1 degree at the pole is not the same as 1 degree at the equator, right? So when you're dealing with distances like this, you want to use a geography type. So here notice we're not having to give the projection because it actually knows it's 4326. It says geography assumes 4326, and the distance between Los Angeles and Paris is 9,124,665 meters. It always returns its results in meters, right? So if we wanted to, well, I'm not going to, we could divide that by 1,000 and we get kilometers, which is 9,000 kilometers basically between Los Angeles and Paris. And that is accurate, right? That is the actual real Great Globe distance. So that's what it deals with, right? So you can take a geography from text, right? And so here's Iceland, right? Here's another one. You can do it you can even calculate distances between a line string. So this is LAX to, I don't know, what's CDG? Does anybody know what airport that is? Charles de Gaulle. Right. So this line string is making the great circle distance between LAX and Charles de Gaulle Airport. And then it's saying, what's the distance from that from the Iceland airport? And so it's 500 kilometers, right? No, 1,000. Yeah. 500 kilometers is the closest distance that plane will ever come, if you don't include altitude and stuff, from the Iceland airport. Does that make sense?
Yeah.
Right. So
Steve, come again.
Go ahead.
Steve, come again.
Say that again.
Steve. Come again. Can you go over that again?
Yes, I can go over that again.
Yes.
Okay. So is that you? That's John, right? That was it talking?
Yeah, this is John.
Okay. So John, do you understand this ST distance one up here? So the geography type assumes that the coordinates you're putting in are actually are coordinates on a sphere.
Okay.
Right? It's not assuming that they're projected. They're not. It's not an UTM. The units for geography are going to be decimal degrees, longitude, latitude, and they're on a sphere. So when we do this distance between Los Angeles Airport and Charles de Gaulle Airport, it's actually calculating the Great Circle distance, not the as a crow flies distance. Does that make sense? Like, you know, on a, assuming you can go straight through some projection.
Yes, it makes sense. Yeah.
Okay. So then what this ST distance function is doing here, this first part of this is actually a line. Right?
Okay.
And it's defining a line between LAX and Charles de Gaulle Airport. So take that Great Circle, imagine taking that Great Circle distance that we calculated before and now make that a line on the globe.
Oh, okay.
Okay, so that's what that's defining right there. And what now we're calculating distance between is that line on the globe and the point for Iceland's airport. So the closest, so basically what distance does between a line and a point is it says, what's the closest that point ever gets to that line? And so the closest that Iceland's airport gets to that Great Circle line is 502,000 meters, which is the same as saying 502 kilometers.
Oh, okay. I got it.
Okay, good. Cool.
And could you explain again how you're getting the meters out of that? How is it returning meters instead of degrees?
By default, with the geography type, whenever it does any calculation, it returns it in human readable meters.
Steve, do a /df st underscore distance star. St underscore distance star.
Oh, yeah.
So if you look at this list, you're going to see that there's multiple calls to that function. That second column says st distance. That is what is called when you're running that st distance function. If you look on the argument data types on the right, you see geography, geography, and if you look further down, you see geometry, geometry. What's happening here is when you have a geometry type, it's calling the distance type that uses the argument list for geometries. When you're using the argument type for geometries, since they're projected, we have no idea what the underlying projection is. It could be inches, feet, meters, degrees, flibbity, flobbity, whatever you want to call it. Geography has a hard type that says we are doing a great sphere calculation. So all calculations in that are the full Haber-sign on a great sphere. And because of that, it forces it to be in a projection that returns meters always.
Yeah.
So this
it
three
actually doesn't
commands
force it
up,
to be in
you
a
return
projection.
the
Wait. It doesn't, basically it converts, it doesn't force it to be in a projection. It just does all its units and returns in meters.
Correct. The understanding on a geography type is that it's generally projected to 4326.
Yeah.
But Steve's absolutely right there.
Go ahead.
So how come 3 commands up it returned degrees? I missed that.
Because that was working against geometry types.
Yeah, so look, this says ST geography from text. This one says ST geometry from text.
Whoa, okay.
Right?
Okay, thanks.
So that the first exercise was to show if you do it you could use the same coordinate system that you could use geometry types like we did before. It's the right geometry type, it's the right projection, it's 4326. But it doesn't do the calculations in a way that's appropriate for distances like that across the sphere, right? It returns degrees because that's basically for geometry types. It says whatever units you pass in, that's the units I'm doing my calculations in. If it's a geometry type, I'm going to do all my calculations in whatever units. I'm going to pretend we're back in high school geometry. You know, the square root, the distance between a and b is the square root of a squared plus b squared, right? Which is the hypotenuse, right? It's going to do geometry types. That's all it's going to do. Geography types, it says, whoa, we can't do that. We're actually on a globe. We're going to do all our calculations assuming we're on a globe. As if you pass in any geography type to any function that accepts geography types, it says, oh, I'm on a globe. I'm going to use the right formulas for a globe. And I'm going to always return whatever units to you in meters. That make sense?
More or less, yeah. Thanks a lot.
Sure. So what's the nice part about, for those of you who know 4326 and geography types, you will also know that that is what comes off a GPS unit in general, unless you have a fancy GPS unit and you set it to return its units in a projection. In general, what comes off of a GPS unit, like on a phone, is longitude, latitude, 4326. So if you are working with stuff that's coming off of a phone, you can store this directly into a geography column, and you can store it directly into a geography column, do all your calculations and operations that are supported, and get your units back in meters without having to deal with anything else. Does that make sense?
Mm-hmm.
Okay. So, sorry, say again.
I was just gonna have a quick question.
Sure.
Would let's say your PostGIS database is backing like a web feature server.
Yeah.
Would having, since most web stuff is either Web Mercator, right, 3857 or 4326.
Yeah.
Would this have positive performance implications if you were to store and serve geographies, or would it really be constrained by the size and number of features, or am I not understanding the benefit?
No, you're getting part of it right. So the thing is, it depends on what you're going to want to do with your data. So if your web feature service is, if you don't allow people to really do calculations with it, right, it's just straight up giving features back, then I would probably just store it in a geometry type, right? There's more, it's straighter and faster. Anytime, because we have to do all these calculations in globe space rather than square root of a squared plus b squared space, it's a little bit more intensive, right? So for just straight web feature service, if there's no calculations allowed, you're just returning features to users, I would probably use just although I don't know if you're just returning it, I don't know if there's much difference either way.
I have some comments there too, Steve.
Sure, go ahead.
If you're using it in 3857, you're going to need to keep it in a geometry type for the first portion, but there's a cost to converting the projections between that and 4326. If you are using 4326, I generally recommend keeping it in a geometry type just because there are a larger amount of functions to it, which is further down in this slide for Steve.
Yeah.
And the cost of casting from geometry to geography is almost negligible because how it's stored in PostGIS is identical. It's just that it kicks off a different set of functionality.
Right, so can I just explain that a little bit?
Purposes, real quick.
Okay.
If you're doing small calculations of close together things, if I'm saying who's the closest person to me, a geometry is fine because you're never going to kick off into the distance calculation where circle calculations matter. But if you're a plane that's flying around and says, hey, I ran out of gas, what's the closest airport? Geography calculations become important. So it also depends on the scale of what you're doing, not just the scale of what you're keeping in the database.
Yep.
Thank you.
All those things. And again, that's where casting comes important. Like, then this is what I wanted to just what John said. You can always, right? You could do here, if we do, oh no, he's doing geography from text. But I think I can actually do what he was talking. Let's see if this works. I've never done this before, but let's try
The other
this.
command is geog from text too, and yeah, that does work.
So I'm going to say, look, I'm going to cast this back to a geometry type. Do you get what I'm doing here? Does that make sense? This is that casting. So what I'm saying is, yeah. This is you made a geometry here. I mean, you made a geography here. Actually, cast it back to a geometry and do the calculations using the geometry type. Right. So it's going to use this function rather than the geography function because I'm casting in two geometries now. So now we get our distance back in degrees because I've actually done the casting to put it back into a geometry. So there are functions which don't accept geographies. And so what you can do is you can actually, if you wanted to use those this, for everybody else, ignore this. This is only for this guy who's asking which store to store it in. If you ever needed one of those functions, you can cast in as a geometry and then get that function, even if it's not supported by geography. Does that make sense? Cast, John, the guy who asked that question.
You got nods.
Okay. Okay. I'm going to skip all this other stuff. I'm going to go back down to, I'm going to skip all this stuff too. Oh, here we do. So we're going to, this is new SQL for everybody too, which is interesting. So we had our original table, right? Oops. We had our original table of the subway stations, which were points, right? And that was in UTM North, right? And we want a new table. So we're going to make a new, we're saying create a table, call it New York City subway stations underscore geog as, and so we're creating a table by doing a select statement. So we say select geography, so transform our geometries from, the first thing we do is transform our geometries from UTM North to 4326, right? So that's this ST transform. And then this we say, and now make that a geography, store that as the geography column as geog, name, and then routes, which routes it serves, right? And do that select statement on New York City subway stations. So we're doing a select, take this is basically a normal select, but we're saying rather than spitting the output to the screen, like we saw before, save that as a new table. Okay, so we make that table. And then because we want our queries to go fast, we're going to create an index on the geography column. So we're creating this index of type gist, which is what you do in spatial. And I'm not going to talk about what a gist index is right now because everybody's brain is probably already full. So I'm just going to say you usually make a gist index on spatial data in PostGIS after you've created the data. Okay, it just makes things run much faster. And so PMM Melissa, this is part of one of the things I was talking about with performance. So here's the, see, there's much fewer functions for geography types. These are the only functions as of, this was probably PostGIS 2.5 that were supported. There's probably some more that came in 3, I don't know for sure, but there probably are. So you notice there's not as much, but they actually cover most of the things that we, like 80% of the things we usually do as GIS analysts, like, what's the distance? Is this geography within this geography? What's the area of this geography? What's the length? Is this geography covered by this geography? Does this geography intersect? Hey, buffer off this geography, or do intersection between two geographies as well. Okay. This one says, do these intersect? This one actually returns the intersection. So that's a lot of what we do as GIS analysts. We're now going to create an airport table using geographies, and this is how we import them, right? And now if we do our select star from geography columns, this is again looking into that view table, and you can see we have 2 of them. One's in the subway stations and one's in airports. The SRID is not necessarily important in this case because we're storing it as geography, which assumes an SRID of 4326. I already showed you how to cast a geometry. I'm not going to do that again, just because you've seen it. I just showed it. You just do the casting.
Question.
Yep,
So
go.
you just created that table, right?
Yeah.
But if you go up, the language said to call it geo. Call it geo. So right before this stage.
You mean the select statement, this select one up here?
Yeah, did you click on that one? Or no?
I did, see, but it said it said create this as the table as geog, which is this table name here. And then what it does to make the column names is it uses the names of the different columns in the select statement. Okay. So here we did the geography, we transformed the geometry into a geography, and we said, but name it geog.
Yeah. I guess I thought it would be the label, the column name label rather than in the box.
No, it's always the name of whatever we say as.
Okay.
So if we hadn't, right? So let me do that statement again.
Okay.
And I'll show you how we can get, I'll make a third table, right? So where is that? Okay. So if I call this Geog2,
Uh-huh.
right,
Ah, yeah.
I'm going to call this table Geog2 because I don't want to overwrite my others. And then if I get rid of this as part here,
Mm-hmm.
right, so I'm going to get rid of the as part. What we end up with now, if I do my show me the geography columns, you'll see this geography column is called geography.
Okay.
Right? It's the return, because we did this geography call. It's the function name again.
Okay.
Does that make sense?
Yes, thank you.
Sure. Okay. So let's see. I don't want to do the casting. Why not geography? So the reasons you wouldn't, there's fewer functions. Second, calculations on the sphere are computationally far more expensive than Cartesian calculations, right? So the Cartesian formula for distance is just one call to square root. The spherical formula for distance, Habersign call, involves 2 square root calls, an arctangent call, 4 sine calls, and 2 cosine calls, right? So trigonometric functions are very costly, and spherical calculations involves a lot of them. So if you're not going to be doing things that where you like John said, the part where this really matters is when things are far apart on the globe. Even if you're probably, when the curve starts to matter, because if we remember high school geometry, the intersection of a plane and a sphere is like a plane. So where that plane intersects, if it's small enough, you can actually just use planar calculations. But like, for example, it depends on how accurate you need to be. Even with projections, the state of California is too big, right? We actually have 3 state plane projections in California because calculations would be off if we tried to do 1 state plane projection. So if you're within a county in the United States, unless it's maybe a Texas county, because some Texas counties are really, really large, and some California ones too, actually, like Riverside County is pretty large. Or San Bernardino County is pretty large. Within a county, you probably can get away with treating it as a geography type, a geometry type, sorry, a projected type. But if you get much larger than that, you're probably going to want to switch to geographies. Okay. Okay. Here's some of the functions, footnotes. Let's continue. That's the whole thing on geography types. Any other questions on geography types? Okay. We're going to go on now then to projecting your spatial data. Projection is actually pretty complicated in general. So I'm not going to go too far in depth on this one. I'm just going to show some simple how you can do some projections. Okay, so we'll start the scenario. PMM people, do you know the basic idea of projections? So the 2 Melissas and anybody else who's not a GIS person, do you understand projections, or at least know what it means? Okay. So, okay, good. So I'm not going to go into too much. I'm just going to say, look, you can get the SRID, which you can use in the site. Was it Brett or John? I don't remember who gave me that site before. There was this, spatialreference.org or the epsg.io. You can use that to look up the projections that come back from that query, right? So that's the 26918 is 26918 is the projection for our data. Newtm zone New York North. We did that before. We looked it up. Blah blah blah. What's fun, and I've seen this before, projections actually matter. So if you take the 0.00 in 4326 and you do it in 26918, they're not the same, right? It's gonna. You can't compare data from 2 different projections, right? You're going to have to get them into the same projection. So what we do here, okay, I'm not going to go into all this because we understand it. The way you can do it, you saw it before, is if you don't have a projection already set on it, you can use a set SRID, right? But the function you're usually going to call, like if you want to project between two in a data set, is this st transform. Right? St transform basically says, give me a geometry. As long as it has an SRID already set, I'll transform it to this new SRID. Okay, and that's usually what you want to do. And you saw that also in our geography type, right? Before I could actually make it a geography, I had to take it from UTM and make it into 4326. So you saw me st transform to 4326 and then make it into a geography. Make sense? Everybody get that?
Mm-hmm.
Okay. So that's it. That's all we're going to show about transforming for here. Is that okay? One note that I have come across before, though, is here, and it's important. Let's say you're querying, you have like in QGIS, you set your query to get the data back in Transform Web Mercator, or your web app is getting the data back in Web Mercator. If you want the index to actually be able to take advantage of it, you have to make a separate index with that projection. Does that make sense? So if I look, right, if we look at, let's actually look at, while we're here, DT, what was it? NY, what are our tables again? Oops. /D. This just tells us our tables. We made airports. Those are all in group. We wanted, let's do New York City streets. So /DT NYC streets, right? Ugh. I want /D describe New York City streets. Sorry. So it's got its geom type, which is in 26918. There's a gist index on it, on the geom type. That index is going to be in projection 26918. This index is going to be on projection 918. If you're going to use Web Mercator, right? If you want to start doing queries in Web Mercator, you're going to have to do another index on Web Mercator. Why is that? Because when you're passing in bounding boxes or anything like that, that's what's actually what the query is going to look like. So if you're passing in coordinates from Web Mercator, are those units going to match the units that are actually in 26918? That's a question for everybody here. That's a thought question. Will the coordinates for, let's say, Wall Street be the same? If I look at the X and Y's, will it be the same in 26918 versus Web Mercator? No, right? Because it's separate projections. So if you pass in a bounding box query from your web query that's in Web Mercator, it's not going to be able to use that index because the coordinates are not in the right projection. So if you're having multiple people access that data and some are passing in queries in a different projection, typically this is going to happen with Web Mercator. You're going to need to make another index called that does an ST transform to Web Mercator when you make the index. So we could, John, help me out on this because you are more fluent than me, but I think it's create index, and then we give it the name, and we'll just call this Web Merc streets on, is it on?
Yeah, on table.
Table, so it's going to be NYC streets. And then we're going to say using gist, right? And then you say ST transform.
You're missing the column name.
Oh, no, the column name goes, wait, the column, I'm going to do it, I promise.
Yeah, you're right.
ST transform. And then we say geom, but then does anybody know off the top of the head what the projection is for Web? Here, let's look this up. Search. This is it right here, 3857. So then we would say in here, 3857, right? What did I get wrong?
Parens.
Oh, around the whole statement.
Around the using statement.
Yeah.
Not the using statement, the SC transform.
The whole thing. There needs to be parens around this. Yeah. Thank you. And so now if we do a D on that table, if we describe that table again, you'll see there's two indexes, one on Geom using its 26918 coordinates and another one using 3857. And so now a query coming in Web Mercator will be able to take advantage of that index. Does that make sense to everybody? Okay, so if you're using your PostGIS database with multiple people querying off of it, and some of them are querying from another projection system, and you want it to be fast for them, you need to make an index in their projection. Okay? We cool? We good? Bye,
So,
Jenny.
Just one question.
Yeah.
I don't see the index inside the table, right? It's like I don't know. It's like a structural data of the database and of that table, right? I mean, I won't have an extra column containing the indexes I'm creating for every projection, right?
No, that data is stored outside of the table in a separate data structure. That when we make a query, the query planner knows to go look at that data to help it make better queries.
Okay.
It does take up space, though. Just so you know, it does take up space, but it does not take up space inside your table. So queries are not. I mean, indexes are not free. You can't just make indexes willy-nilly. Right?
Yeah, of course.
Be wary of that, right? Because sometimes people say, "Oh, well, indexes is the answer to every question I have about performance," and that is not true. Okay, you can actually get yourself in trouble if you make too many indexes for things that don't need it. I think I don't know if this D plus will actually give me the index sizes. No, I think if you do /D plus here, it'll give you table sizes. Right, so if you do /D plus, so now we know New York City streets is about 4 megs in size in the database. Probably if I do D plus, what's D? Is it DI for indices? Do you know, John? Lowercase I?
Yeah, I'm not sure. I don't use that command a lot. There is
here's the indices.
Index size too.
Here they go. So you can see there's Merck streets, the one we made. That's about 2 megs in size. So the whole table, don't forget, for streets was 4 megs. The index is 2 megs.
Okay.
So just keep that in mind when you make indices. Some are bigger, some are smaller, but from streets, because there's a lot of geometries in streets, right? And basically, when we make an index in PostGIS, we're basically making a bounding box for every single geometry. That's what the index contains, bounding boxes for every geometry in there. All right, so we're done with projection. Should we do one more and then take a break? Okay. So now we're actually getting to the fun stuff. Fun stuff time, fun stuff. Analyzing spatial relationships. Okay. So we got our data, same data again. Now what we're doing is we're going to do intersection. So this is how you do, this is probably one of the first things you learned in your GIS class. After you learned about points, lines, and polygons and rasters and that stuff. Then you learn, okay, let's do an intersection between these two layers. So this one's going to intersect a point and a line. It just looks like ST intersects. And the answer is true. The point, this one's saying, do these things intersect? ST intersect says, do these things intersect? Yes or no? And so we're saying, does the point 1, 1 intersect with the line string 1, 1, 2, 2? And the answer is yes, right? Because that point is the same as the beginning point. All right. So here we're going to use that. We're going to get the geometry as text for Broad Street. Oh no, it's the subway station. Sorry. There's the point for the Broad Street subway station. We good?
Mm-hmm.
Okay. Okay, so we don't care about this actually, right? We're going to just keep going. Oh, what they're doing here is he's using it. What he's doing is he's using the geometry in a where clause. So he's saying, oh, look, I want to select from the subway stations where the geometry equals the binary representation, which so we get Broad Street. So that's not that important. It's just setting stuff up. Now we're going to do intersects. So we're going to say select from the neighborhoods where the geometry of the neighborhood intersects. We're going to basically give back this point right here as text, right? We're not doing a join or anything. We're just like, oh, we know that's the point. Give me back what subway station is, what neighborhood is that subway station in? And we get the financial district, Manhattan. Does that make sense? We remember the ST intersect says true or false. Where does this geometry intersect this geometry, two geometries? We're saying, do these two geometries intersect? So when we do this statement, what the database does, very broadly speaking, this is not the actual algorithm it uses, but what it broadly does is it goes through every single one of the neighborhood polygons, and it says, hey, is this point in this polygon? Does this point intersect this polygon? Does this point intersect this polygon? Does this point intersect this polygon? And so the only one that returns true, because we're using it in the where clause here, is the financial district. Make sense?
Mm-hmm.
Okay. So you can also do the opposite, which is disjoint. You could say, I want all the polygon, I want only the polygons that don't intersect this point. And that's just disjoint. And now I'm going to do something, I'm going to do that on this one, but I want to know how many disjoint, but I don't want all these back. So I'm just going to do count. And we'll just do name. I mean, you can just use star as well. It doesn't matter. But we'll just say, just count how many rows. 128 neighborhoods do not intersect the Broad Street. The Broad Street subway station. Is that good? Everybody get it? Cool?
But when you do that, it's only the neighborhoods. What about other things? Could you do the blocks instead of neighborhoods?
Yep, I could use that point with any of the, so I can do the same thing. So select, actually I could even, I wonder if they actually, let's go back up to the original. And I wonder if, how they situated the subway stations, if they actually put them right on the streets. We can even try, what was it, like New York City streets? Was that what it was called?
You had something that said streets and blocks and neighborhoods, and what was the other one?
Oh, there's no borough name.
No.
In streets, so I got to get rid of borough name. It says you're asking for a column to return that I don't know. So no, they didn't situate the subway stations, but there was another one called boroughs.
Mm-hmm.
Right, from NYC, was it just boroughs? BRROS?
Oh, I don't know. I don't remember.
No. What was it called?
There is no boroughs. Borough name is in the neighborhood column.
Oh, okay.
Census blocks, I think, is what we're looking at too.
Okay, so here.
Maybe that's.
So is it NYC census _ blocks?
Yes.
There we go. And I don't think there's a name column in that one. I think there's just there's probably like a block ID. Is it that? BLK ID?
GID or BLK ID.
Yeah. So there's the block. That's the census block that subway, the subway station's in. Broad Street for subway station. Okay. You can use it with any of your layers you have, right? So where this would happen, like in a web app or something like that, or some other thing, is in a web app, someone would pass in here, like they would click on the map, you get the coordinates from that click, and then you'd say, give me information back about the counting underneath that click, right? That you're using it in the where clause just like that. All right, so let's continue. You can do within, contains, you can do all, you can returns true if it's actually completely within, right? It has at least or completely within the section. So it has to be completely, the first one has to be completely within, and they have at least one interior point in common. So contains, if one contains the other geometry, right? So contains tests for the opposite relationship of ST within. Okay, so ST contains AB is equal to ST within BA, right? They're opposites. It just depends on which order you put the geometries in. Let's see what else we got. ST covers and covered by, right? So this one, this has the quirk that polygons do not contain line strings, which lie along their edge, right? So if a polygon will not contain a line if they share, if it basically that line is the edge or touches the edge, because it's not actually with, they don't share a within point, right? So covers actually says, yeah, they actually do, right? So here, this is ST contains this line. You can see the line string basically touches the outside. It just goes from 0, 0 to 1, 1. It's sharing one edge of the box. This is a box here, right? So it comes back false. But if I do it, does it cover? It'll come back true because the polygon actually covers the line, right? So that's cover. And then crosses and overlaps and touches, right? So what is this, for those of you who are QGIS users or ArcGIS users, what does this look like? These are most of your geoprocessing, the very basic geoprocessing functions, right? So this is when you do like a clip and a cross and you can do all those exact same things using your SQL statement, right? Except it'll be a lot faster is what happens here, right? And then there's overlaps and touches, right? So touches if either the geometries intersect or if only one of the geometry intersects the other's boundary, right? You can do touch, overlaps, crosses. There's relate. So relate is a little bit different. Have you guys, did you ever see the full dimensionally extended 9 intersection model, DEM, 9IM? You can do it in it used to be ArcInfo. Do you remember how in ArcGIS desktop you could get into the ArcInfo piece of it and it had like some advanced spatial functions? Basically what it is I'm not going to cover it here now. What it does is you define a 9-digit or 9-character string of the relationship, right? The pattern mask for crosses is like true, star, 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 true, star, star. You can define all sorts of relationships. I don't know, did he put a link in for it? Here, let me just do a search on this so you can see it, right? So is this it? This is actually, I think, from ArcGIS. This is from, it's like a 9 here, right? So like intersects, boundaries, interior, boundary, exterior is what it means by the 9, right? And so you have 2 features. And so then you want to say, do these intersect? And so that, it's basically walking through this grid for true, true, false, false, true, true, false, false, true, true, true. So you can specify really complex relationships if you really need to get into that using this 9-dimensional intersection model. I'm not going to teach you that today. That's enough. You need to go figure that out on your own. Just know that if things aren't covered by any of the crosses, overlaps within, you want some really complicated geometry relationship model, the 9 extended model covers all possible use cases. Okay? So you can say like shares an interior but doesn't share a boundary and doesn't share an exterior. You can do that using that 9 model. And it's supported here. So here's an example. These 2 polygons, right? And it comes back with true between those 2 polygons. Right? Here's 2 polygons whose interiors intersect and thus do not form a polygon coverage. Right? The polygonal over coverage, there's no coverage between them. right? And here's where they do. And it says yes, right? So just know that you can do it if you need it. Other ones are like ST distance. You can collect the distance between 2 points, right? So here's the distance between this 0.05 and this -2 to 2 to 2 to 2, right? So between those lines, and the distance is 3 in those arbitrary units. But we covered this before with the geography type. Right? That's the units that come back. That's the ST distance, right? You can actually do an STD within. So in this case, you're going to want to know if two objects are within a certain distance of each other. Right? So this is actually for more using inside of a where clause. You can use it inside of a where clause, right? So here we're going to say, select from the streets where the distance is within 10 original units. And so since it's UTM North in meters, we're going to say, find a street that's within 10 meters of that Broad Street station. And there you go. We get Wall Street, Broad Street, and Nassau Street. So if you're on all three of those streets, some part of those is within 10 meters of the Broad Street station. Right? That make sense? And then they say you can answer on the map. The Broad Street station is actually on the intersections of Wall, Broad, and Nassau Streets. Any questions about any of those? I mean, I think you know most of these spatial functions, right? I think what I'm hoping is coming through for you guys, said in the northeastern sense of the term, guys, is that everything that you used to do on your desktop GIS, you can actually combine that together and use that in your SQL clauses and have it scripted and executed all the time if you want, right? So here's some exercises we can do. Do you want me to go through them? Or do you want me to, or you want to go on some more? Because we're technically out of time, right? It's 12 o'clock and I don't, people's lunches and all that other stuff. I can go through these exercises. You can go through them on your own at home. We can do, no, I'm not going through them because there's one other really cool thing I want to show you. Let's see so there's the summary of all the functions and relate functions and distance functions. These are like your bread and butter right here. You're going to want to know these, right? And they're all there. Go through this exercise on your own. I want to show you one which actually came up in Twitter the other day where we helped someone out, and it was a spatial join. Do you guys know what spatial joins are? Right? No. So a spatial join is where you have two tables, right? Both of which have geometries in them, but they have no link, like in a normal join, right? In a normal table join, you have a column where you say this refers to this, and so therefore these two tables are related, right? So for like example, in like a people and taxes table, you'll have the social security number in the people's table as their unique identifier, and for their tax return, you'll also have the social security number so that you can say this tax return belongs to this person. Right? And that's the way databases usually do things for joins when they want to bring two tables together, is they'll do it based off of some common shared column where they share information. So what this person was trying to do was they had a customer and they wanted to get was it the county name? They wanted to get the county name. No, not the county. Yeah, the county name, not the city name. Was it that? Or they wanted to get the zip 4. They wanted to get something where they had all the information. They had the point for the customer. They didn't have the zip code, let's just say, but they had a zip code coverage table, like a geometry table, right? And they wanted to get, they were like, I'm going to try to doing an address match. I don't have the zip code, but I'm going to try to get their zip code because I have city and street names and I'm going to do geocoding and try to get it to work. And a bunch of us were like, no, you just want to do a spatial join. Because what a spatial join does is it says, bring these two tables together based on shared geometry. Right? And so that's what a spatial join is. It's really powerful. And I'll show you how you do it in PostGIS. So here we have, we're gonna do a join between two tables, right? And we're gonna do a spatial join. We're going to say where the subway names, the stop equals Broad Street, join the neighborhood table and the subway table, right? So I want to know what neighborhood is SD contains, right? So which neighborhood contains the subway station where the subway name is equal to Broad Street? And the answer is the financial district in Manhattan. I didn't have to actually enter the coordinates this time. Do you remember how last time we were entering the coordinates to get this information? We said where the point SD contains, and then we had to hand put in the point. In this case, we don't have to do that. We're saying join New York City subway stations as subways on the neighborhood's geom, whatever they're contained in that geometry table. The neighborhood geometry. So we're joining on where they contain. You could do it within as well, right? But you can also use this for really, so does everybody get it? Am I like talking way past the cell? Should I stop?
No, it's fine.
Demonstrating it?
Good. You're good.
I'm good?
We're okay.
Okay. So I want to do this next one as well, right? The next one is, if we look at, and I'll do this the way I really want to do it. If we look at the census data, right? So it was NYC, was it census blocks, right? We have a geometry, but there's a borough name, right? But we don't actually have anything that has a neighborhood name. So what if we wanted to actually look at the block groups that make up a neighborhood? How would we do that? We couldn't do it. There's nothing that we can do to join in the normal database way the neighborhood, because if we look at the neighborhood table, come back to, was it called, is there a neighborhoods table? Yeah. If we look at the neighborhoods table, right, there is nothing that we can actually join a block group directly to the neighborhood. There's no reference in the neighborhood table to the block table. There's no block ID, and the census table has no neighborhood ID, right? We have a borough, but the boroughs may not map one-to-one between neighborhoods and blocks, so we can't really use boroughs. So the only way we can solve this is by doing a spatial join. And the way we do that, all this part before the select is just calculating the information we want, right? We want to see the neighborhood name. We want to sum how much population. We want to do a percentage of how white that neighborhood is. We also want to do as how black that neighborhood is. What's the percentage of black people in the neighborhood, right? And we're going to grab the neighborhood table and we're going to join that to the census table where the neighborhood geometry intersects the census geometry. So for every single block, where the neighborhood name equals Manhattan, so for every single census block, we're going to say, do you intersect the neighborhood name Manhattan? Do you intersect the neighborhood name Manhattan? Go through and go through, go through, go through, go through, go through. For all the census ones that do, we're going to group by the different Manhattan, all the different geometries in Manhattan. We're going to group by those, and then we're going to calculate the statistics on them. So if I do that, you get these are all within Manhattan, because that's the borough name. These are all the different, for all the different neighborhoods within there, we took all the censuses and summed the population, all the different block groups, and then we calculated the percentage black and white for each of those neighborhoods using the block group data. And the only way we could do that is because they share geometries. Does that make sense?
Yeah.
Okay. So this is something that I think would be a little bit harder to do in a desktop GIS. Okay. And then you can compare that. So the other fun part is here we're doing, this is not a join, but they're going to do the racial makeup of the entire city, right? So they're just going to do the percentage of the blocks group table. And then the fun part you can do now is you can look at how much each different district compares to the normal, to the overall, not to the normal, to the overall, right? And so you can see this number hides a lot of geographic variation, if you look at it as well. It looks like actually most of New York is quite segregated. Most of the neighborhoods in New York are quite segregated, even though the overall percentage would tell you that it's not. Do you see that? Right, the overall says it's 44% white and 25% black. But if you go in and look, most of the neighborhoods are less than 10% black, right? And predominantly, and much higher percentages of white. It's just Harlem and maybe Washington Heights and Morningside Heights and Yorkville that have, and there was an East Harlem too, and East Harlem, right? That have the higher percentages. So just interesting stuff you can do. So let's see, anything else that I should? Oh, here's another interesting one. So this is a spatial join that's using within. Okay, so on this one, we're going to select basically string position says, this little function here says, give me the location of this string within this text field. So what we're saying here is give me the position of this string A within this text field, which is subway routes, right? And so if it's greater than 0, that means there's actually an A in it, right? That's saying if it was 0, that means it didn't find A. So here's all the different subway routes, right? That contain, sorry, that have the routes A in them. That's the A train line, right? And then this query, which is really powerful once you start to learn the SQL stuff, is same percentages we're calculating again. Now we're joining census block groups against subways, where we want to know any block group that is within 200 meters of a subway stop that services the A train. Right, so we're saying, okay, should I walk through that one more time? People with cameras on, I'm actually looking at you to say what you're...
Yeah, go for it.
Okay, so let's start. The select statement's the same. Does everybody see that? Do I need to explain the select statement again? The select part? That's good, right? We're just calculating those percentages again. We're grabbing the census table and the subway table. So those are the two, because we want to know what's near the A line. So the first thing we're going to do is we're going to say, look, I only want subway stops that service the A line. Okay, so that was the string before where we did. This is that where query we did before that says, show me all the routes that have an A line in them. So now we're going to do a join on those subway points that have the A line in them. And we're going to go through each one of those. For each one of those, we're going to compare those to all the census block groups and say which census block groups are within 200 meters of any of those 9 subway stations that service the A line. Does that make sense? Now in the query? This within, remember within, back when we did within before, that actually does a buffer. Like show me all the things within this distance of this other thing. Make sense? now?
Yeah.
So now you can see the racial makeup within 200 meters along the A line isn't very different from New York City as a whole. We could actually group it by, we could actually, let's see if we can do this.
Okay, wait.
Oh, yeah.
You took the population grouping of race, and then you asked it for the street, the train, and the race, and give you the results for the A line.
What I did is, so I said, look, calculate the percentages. I want to calculate the percentages of white block group. I want to calculate the percentage of white people and the percentage of black people on this, according to the census, and of the number of people total for all the block groups that are within 200 meters of a subway stop on the A line.
Okay.
Right? The way we did that is we said first, so these are the numbers, the top part is the numbers I'm calculating, right? The way we actually got it to just that data set, sorry, I've got you guys on this window over here, so I keep looking this way when I'm talking to you, even though I should be looking this way.
I figured that.
So the way I got to this, reduce the data set.
I just want to let you know that, sorry to interrupt, but Guido sent out a message, I don't know if you saw it, that said the room's going to be closing at 12:15, so that's in like 2 minutes.
15 or 12:30, no?
I could have sworn it said 12:15. Oh, I'm sorry. Maybe it did say 12:30.
I'm going to look.
Ignore me.
No, is it in general?
I don't know. I just saw it flash on the screen.
In our chat?
It just flashed up on top of the screen.
I didn't see it.
Yeah, it flashed on mine too. It said 12:30. And
I'm sorry.
Zone, so I'm going to assume that's going to be 12:30 Eastern Standard.
Yeah,
because otherwise we're going to be on here for another 3 hours if it's Pacific time. And I feel bad for you if that's what the case is, because it'll be painful by that point. So again, just to go through this one time, because this is so just one last thing I want to say about, well, not one last thing. One thing I want to say before I go through this one more time. I do not expect you to completely understand this query right now, right? This query, like I understand it. I might have been able to write this query. Paul Ramsey wrote this query. So this is kind of like, how do I say it? What's another way of thinking of this?
Throw the explain up if you can too, to really confuse people.
No, I'm not going to do that. Their heads are already full. I'm not doing that. This is what you should aspire to in a couple of years or a year, is being able, like, think of how long it took you to really do things well in ArcGIS Desktop or QGIS. You didn't just start doing that stuff right away, right? You probably took a class and you had a professor and you went through exercises, or you spent years with somebody showing you how to do all this stuff. Like, I don't expect you to basically know how to be able to write this now. That wasn't the point. Oh, the environment died anyway. So I'm going to wrap up no matter what. I don't have to run the query again. I can explain it. But this is what you're going to aspire to, and the power of what you can get in one line that you can write as a job. So again, the way we did this is we said, look, we want all subway routes along the A line. So that query we figured out back up here.
Right.
So these are all those, this is how we figured out, oh yeah, okay, this is how we just get the subway stations that are on the A line. Now, so that's what we did, right? And as opposed to the one we did before, where we said where they intersect, we already saw before that the subway stations don't actually lie right along there. We actually want to know within 200 meters of all those subway stations, give me the block groups around them. So we're going to say within. So we're going to say for all of these stations, which is subways.geom that comes back here, give me, for all the geometries that come back for these subways here, buffer 200 meters and select those block groups and use those block groups to calculate these numbers. That's what we did here.
So
it's like
possibly to help, one of the things you mentioned earlier is thinking iteratively versus thinking set-wise. If you think of this as a set-wise function, what you're doing is the first from is setting up set one. Your first from is setting up the get everything from the NYC census blocks portion. Your second set is the NYC subway stations and is filtered by that where clause. The where clause that says string position subway routes.a is filtering your second set to only include the ones that have the A in them, which Steve showed in the previous, well, the count of it in the previous query. Then what's happening is now that you have your two sets set up, that join is taking those two sets and merging them together on that on clause condition. That on clause is telling you to take the two sets and only look between set A, census.geom, and set B, subways.geom, and find the sets that are overlapping within 200 meters of each other. And that's how you're getting back only that information. What's then hidden is the fact that the select clause is only returning the sums of all those numbers. So the two sets merged together is returning probably 1,000, 100, 500 different census blocks of information, but the sums in the total population is merging those down to one line that's being returned. And that's, like Steve said, all happening in one powerful line of SQL query.
Right. If you were to write this yourself in Python or something like that, you'd actually have to go through and do all that summing yourself. One question, can multiple people edit the same tables in the database at the same time? Yes, they can. This is not multi-version editing, though, like you expect with ArcGIS Desktop, right, or an SDE database. The database has a way of preventing two people conflicting on writes, but basically the last write in wins, right? So you edit something, someone else edits that same thing, the last one in is going to win. You can't both, depending on how the desktop software works, you can't edit it exactly the same time. You can't update it exactly the same time into the database, but multiple people can work, but this is not multi-versioned editing. There are ways to make your Postgres version multi-versioned if you wanted to. I do not think QGIS would be aware of it, though. You'd have to, the way you would end up doing it is some sort of triggering and some sort of, it would require a bunch of work using database triggers and views and fun stuff like that. So it's not out of the box, you don't get multi-versioned editing. The last thing is I'm going to do my wrap-up slide. So the wrap-up is a bunch of stuff about why it's cool to use PostGIS. You can lower your total cost of ownership. See, business kind of 3-letter acronym. I also sent that in for the government military people especially. I know how much you people really love 3-letter acronyms. One of the things I think that's underappreciated is you increase your freedom to deploy and develop in a way that meets your needs, right? Each new instance of PostGIS doesn't cost your company anything, right? So you can try, spin it up, play with it, use it in your architectures, and that's not going to be like, oh, well, you're spinning up another instance of Oracle. There's another, couple of FTEs of salaries being spent on a database engine, right? You can actually just deploy it the way you want, and you can centralize your data storage. If you take the time, you can get to those kinds of queries. You can get increased performance, better resource utilization, and easier automation of boring tasks. So when I was a GIS analyst, I always hated when the conservation biologists would come to me and go, can you calculate the areas of, can you show me all the points of, and I always wanted to be able to say, here's a little script, run this, you got what you want. Don't bother me with this boring stuff. I'm already over my head with all this other work. So that's the benefit. Again, this is the link to the slides. That's another link to Crunchy Data. And remember, all the stuff you can do again is in learn.crunchydata.com. So if you want to learn more SQL as well. I got a question that says, can you use ArcMap or Pro to edit data in Postgres database? I think that's what Brett said before, is that you can. I don't have a license for ArcGIS Desktop Pro. John, at any of the customers, have you seen them editing using ArcGIS Desktop?
I think I have 1 or 2 of them doing it. It's been a while since I've interacted with them directly. I'm looking at ArcMap's direct website, and it has a connect to Postgres from ArcGIS page, so I'm assuming you can.
Yeah, I think you can. I think the tricky parts is if you're using, you can even use PostGIS for SDE. But if you want to be able to edit that data, you have to say use the PostGIS data types, not the SDE data types, right? You can actually back an SDE instance with PostGIS. You just say use the PostGIS data types, not the SDE data types. And then it's normal PostGIS data that you can interact with through QGIS and all those other stuff. Because SDE does a lot of stuff to a database when you install it.
PostGIS behind the scenes is using a lot of the acronyms you already know, GDAL, Proj4, GIOS, to back all this stuff. So the conversions between things is, the capability is there. It just depends if the individual vendor has implemented them.
So I hope this was helpful. I'll stick around for more questions. Michelle, if you want me to show you, did that Michelle stay around, the one who was asking about how do I spin this up on my desktop?
We have both Michelles.
Oh, I thought one Michelle left. No, I think one Michelle left.
I'm here.
Yeah, the double L Michelle.
I'm still here too.
Oh, you are? You just were saying thanks. You're
Yes.
the nicest, Michelle. Thanks so much. Sorry, Michelle. One L Michelle, you're not my favorite anymore. Double L Michelle's my favorite. Well, because she said thank you first. Is there anything else you want me to just show with QGIS or anything like that, or do you want me to show you any of that? You want me to? Anything you guys want to see here?
Steve, I've got a bit of a question. It might be specific to my instance.
Sure.
We're as Restack right now. I'm
Okay.
trying to convince to migrate to FOSSStack.
Okay.
We don't have a database server. We don't have the license for Arc server.
Okay.
I did play around with PostGIS and setting up a Arc database, a geospatial database within the PostGIS instance.
Yep.
That's where I was saying that, like, without that license, I couldn't share the connection in the
Right.
projects.
Right.
You could edit. It worked great, but only I could get to the data. So if I wanted to share it with my organization, I had to go to everyone's machine and set up that database connection in their Arc install.
Okay. Right.
That's, I think, resolved when you purchase the license for Arc server.
Right.
But
of course it is.
Of course it is, right? We have a network-hosted file geodatabase,
Okay.
which presents some benefits over just folders of shapefiles.
Yep.
But the SQL support's super weak.
Yep.
I don't have the support of IT to spin up a VM or fresh hardware to have a dedicated PostGIS instance, and he doesn't want to put it next to our SQL server.
Yes.
So my plan in the interim would be potentially migrating to GeoPackage because it does have full SQL support.
Yep.
And it gives us a nice middle ground between file-based and hosted.
Yeah.
Do you know, or have you worked with customers that have made that migration? How compatible would database logic be going from GeoPackage to PostGIS? Like, let's say I want to do like the fat database style, where all
Right.
the business logic is in the database and triggers and stuff like that.
Yeah.
Am I wasting my time if the end vision 5 years from now is to go to PostGIS?
So for those who don't know, let me just answer. Let me let everybody know what GeoPackage is first. Is that okay? Okay. So GeoPackage is the FOSS answer to file geodatabases, kind of, or also the replacement to shapefiles. So what a GeoPackage really is a SQLite database. So SQLite is a very lightweight database. It's not even it's a database engine, but doesn't run anything in the background. It's basically like an executable that executes SQL commands against a file system that it's made into a database, right? And so you can ship the SQLite database around, and it acts like a PostGIS database in terms of it's got all its layers and all of its stuff inside of it, but it's a database, not a bunch of shape files or some proprietary file format like a file database. So the question is that a good interim step over if you eventually want to go to PostGIS, but you can't get anybody to install a server yet? Hell yeah. So one, it gets you off of shape files, and two, it gets you thinking in terms of databases, right? So anything that gets you people to start thinking in databases, because there's a client to SQLite that is lets you execute SQL queries and all that stuff. You can get people start thinking in a database way. In terms of doing the advanced functionality, like when he's talking about a fat server rather than a thin server, there's in the database world, there is one of these religious wars. Does everybody know what religious wars, what I mean when I say religious wars in the technology world? Like one of the examples of a religious war in the technology world is which IDE, which editor do you use to edit your files?
Tabs versus spaces.
What?
Tabs versus spaces.
Tabs versus spaces in a file. Do you tab indent or do you use spaces to indent? Right? These are things which there is definitely no arbitrary, there is no definitive, this is the answer. Like there's nothing you can prove. and people will argue about this stuff vehemently for no reason. Just because maybe sometimes I do, sometimes just because it's fun to tweak people, but there's no real reason. John has seen me tweak people on this kind of stuff before inside on our Slack channel.
Two extra points on that too that might help you out. The guys who create it and maintain SQLite used Postgres and pSQL as a lot of their designing guidelines. So you'll see a lot of functionality from one to the other. So if you're moving into that realm, it's good. The other is if you have the time, look into Postgres, OGR, FDW. FDWs are foreign data wrappers that let you open other sources in a Postgres database so that you can migrate to the Postgres database. Paul Ramsey actually wrote the OGR or OGR FDW. So it might be another interim step that you can look at down the road.
Right. So the example with that is you could do OGR FDW to your SQLite database and then use that create table statement to create, then just basically move the database, the table into your actual Postgres database.
Yeah, or the GeoDB so that that GDB still sits there and they still update it whatever way they do, but then you can build the API around that until you get them off the other process.
Right. So in terms of making it what I was going to say about the reason I brought up religious wars is because FatDB versus ThinDB is definitely one of those religious war topics. The difference between a FatDB and a ThinDB, a ThinDB is the database is just storing data and making sure the data is clean and doing all that nice referential integrity stuff. And any business logic lives in your application tier. So business logic in this example is like the intersections that we're doing. And in the GIS world, it's no, I write my geoprocessing script and my geoprocessing script does all the business logic. A FatDB would be where you would write a bunch of SQL functions and then make a view. So like a view is a view of the original data, but transformed. And you would have a view where all those geoprocessing steps are actually carried out behind the scenes in the database. And when the person looks at the final view, all those things are calculated, right? And so all the business logic actually lives in the database tier. You're writing database functions that use PostGIS. You do all this, all the business logic lives in the database, and the user of the database just say, oh, I got my answer. I didn't have to write any of that. I don't have a good answer for you. The way a lot of companies usually try to make this decision is they decide where they have their expertise and where it's easier to maintain that expertise. So companies that have lots of DBAs and lots of database expertise, they're the ones that are more likely to be running FatDBs, right? It also has, sometimes it has a lot to do with who has political power, right? If the DBAs have a lot of political power, they're like, we own the database, all the rules should live in the database. That's usually sometimes the way it goes. I don't have it. My answer to you is whatever works for your organization, right?
Hopefully something, I don't know. We don't have a DBA. We have 2 IT staff, and I'm the only geospatial person to manage all the data for the town. So I'm just trying to.
Right. So if you go with the FatDB, that means you're going to be on the hook for any time anybody wants to change any of the functionality. Right. So I would argue in your case, that is not a good FatDB case.
Fair enough.
Unless you want that pain. So with that, we're going to wrap it up because we got the 5-minute splash and I just don't want everybody. Or we might actually just be done. Thanks, everyone. I don't know if I ever get feedback, but I hope it was helpful for everybody. And maybe you're excited. A couple of you will be excited and start playing with PostGIS. Thanks, everyone.
Thanks. It was great.
Okay.
Thank you very much.
Thanks.
Thank you.
Thanks for the questions. You guys were nice and interactive. It made it easier to teach. Teaching remotely is really hard. So it was really nice to have everybody helping by asking questions and talking.
You said we can go on that other page and practice those sessions?
So all you have to go to is learn.crunchydata.com. It's in the slide links if you got that, but it's learn.crunchydata.com. And then everything we did today is in PostGIS. But if you're new to databases, you probably may also want to do the ones that are in PostgreSQL basics for developers too. That'll cover like how to use the command line, how to create tables, what the different data types are, stuff like that. There should be, once Kat is finished with this, helping me with this, she is also, I think, going to put a new one up on using insert statements, how to do insert data. Right, Kat?
That'll happen today.
See?
Right.
So there'll be new content, fresh.
Fresh off the presses.
Exactly.
Can you export data out of Postgres with as a different format?
Totally. There's a couple different ways to do it. In QGIS, you just take that layer and you just say, you know, once it's in here, you can just say, I don't know, I forget the save layer. I do it all the time, save it to shapefiles. So if you use QGIS, you can totally do it there. There's also that shape to PGSQL can also go the other way around. So you can export from PGSQL to shape. And then the other tool that we talked about is Ogre to Ogre. So OGR to OGR is another command line tool that does it.
Carto should have functionality for it. I don't know it specifically, but inside of the database, there's the ability, like Steve even showed earlier, to put it out as GeoJSON. You can put it out as XML. You can put it out as, and there's generally wrappers to make that into the right things.
Yeah.
And other tools like Ogre to Ogre and ArcGIS, QGIS, etc. that wrap it into a more appropriate style.
Yeah. So here's the name. It's This one's a little bit more complicated to use, Ogre to Ogre, although not really that complicated. You can usually
once you use it once or twice, you know the flags that you do need to use.
Yeah, and there's if all you're doing is going from PostGIS to shapefile, there's a gazillion examples on the web of how to go from PostGIS to shapefiles, because that's a very
Nobody uses shapefiles anymore.
Oh, you'd be surprised. Look at Brett. Brett's like, no. Brett lives that pain every single day of grappling with shapefiles. So broken.
Email back and forth, and then the field names, and then you have more than 255 characters. It's just
yeah. And you only sent me the .shap file. Could you actually please send me these other files? Can you just zip this whole directory up and just send me the whole directory, please? Yeah. I wish your statement was true.
I know. That was a joke.
But yeah, it's good. Because I mean, part of the problem is because Esri just went with file GDB rather than, and they don't support GeoPackage. I think if Esri supported GeoPackage, we could actually finally make the move, because everybody else is.
They sort of knew, and I got like into a little spat with the shapefile account on Twitter over this. So if you're in Arc below Pro, you can access data in GeoPackage, but you can't query it with the information tool, and you can't search it or interact with it. You can just see it. So It's completely useless for end users. And it's just...
We got 35 seconds.
Okay.
Bye, everybody. Hope you have a good afternoon session and the rest of your day.
Thank you.
Bye.
Bye.
Thank you very much. Bye, guys.
Steve. Bye.
Thank you very much, Steve. Bye.
Sure.
Thanks, Steve. Bye.
Sure. Thank you. Bye.